Okay, I'll try to make this quick and painless, people. What we're looking at are sum and difference identities, okay? So they have derivations of these in your book, or you can look online, you can talk to me, we'll show you where we come up with these. But the basic idea of what they call a sum and difference, okay? So sum would be, say, okay, well look, here's angle A right here. And then I've got, say, angle B right here. And I want to know what the sum of those together would be. So it's like angle B, boom, if you put angle B on top of angle A, it would end up being over here, and you'd have angle A plus B. You're looking for the sum of these two angles, okay? Now, a difference situation might be, well, look, over here I have angle A. This is angle A. Oh, and here I have angle B. Sometimes you want to find out what's left in between the two, and that is A minus B. Okay, so a sum and a difference of angles is what we're looking at. Now, I can give you the derivations and we can spend lots of time doing that, or I can simply give you 6 of these identities and ask you to write them down along with your other identities. You should at this point start realizing that you need to have these in front of you. So have a list of identities. Why don't you write them all down? Make a sheet of identities, okay, with your reciprocal identities, your quotient identities, your Pythagorean identities, and then all their other possible derivations as well. And if you have no idea what I'm talking about, then you need to go back and look at those other videos, okay? So what we're doing basically here is looking at these identities, okay? And what I need to show you is a few other things that maybe we've looked at in the past and just remind you of them quickly. So please remember these situations here as well, okay? So what we're looking at here, okay, what we're looking at here is this as being a positive A and this as being a negative A, okay? So if you go, and don't forget all sine, tan, cos. So sine of negative A is going this way. Well, that's going to be the same as sine A, but it's negative because it's in this quadrant. Cos negative A, go down this way. It's going to be the same as cos positive cos A because cos is positive in the fourth quadrant. And similarly, if you go tan of negative A, this way, you end up in the fourth quadrant where tan is negative, so you get negative tan of A. A being essentially this reference angle, right? That occurs in all 4 quadrants. But we're looking at positive and negative here. Okay? That's one thing. Now, the other thing is this. Let's look at these first of all. So what they're saying is that they're complements of each other. What this basically is saying is that sine of 30 is equal to cos of 60. Okay? And it's because there is some symmetry here, right? So if you look at this as being angle A, say, right? And this is being pi over 2 minus A, we'll call it B. Okay, let's call it B. Well, if you look at it, there's some sort of weird symmetry where if you look at this angle, that's opposite and adjacent. And then if you look at this angle, that's opposite and adjacent. So it just so works out that the complements are the same, okay? Now, I'm not going to get into a big, long definition of that here. You need to basically understand that and accept it. And if you'd like more explanation of this, then I'd be happy to give it to you. We'll definitely talk about it in class, okay? Now, the last thing we want to give you before we look at some examples is that if this is true, then these must also be true, okay? Because they are the reciprocals of those, and they work the same way, okay? That would be your identities for 6.4, and now we're going to look at a variety of examples. Okay, so cos 105. Hopefully you can see that that's equal to cos 45 plus 60. Okay, and then from that, what we need to do is look at our cos A plus B, right? That means that this will be cos 45 cos 60. And we're going plus here, so minus sine 45 sine 60. So what we need to do now is figure out what cos 45 is, what sine 45 is, what cos 60 is, and what sine 60 is. Hopefully at this point you can do this. I'm going to do it pretty quick here. That's going to be 1 over root 2. Sine 45 is 1 over root 2. Cos 60 is root 3 over 2. And sine 60 is 1/2, right? So now cos 45 is 1 over root 2. All right, sine 60, or cos 60, sorry, is root 3 over 2. All right, minus sine 45 is 1 over root 2. Sine 60 is 1/2. Okay, so now we just multiply it out. You got root 3 over 2 root 2 minus 1 over 2 root 2, which is equal to root 3 minus 1 over 2 root 2. Now, unfortunately, we don't like to have the radicals in the bottom, so what you do is you multiply by that rational, or that radical, and you end up getting root 6 minus root 2 all over 4. And that would be your final answer for this bad boy. Okay, root 6 minus root 2 all over 4. There you go, an exact value. All right. Let's move down to the next one, sine 15. Sine 15. Well, here we go. So hopefully you can see that's the same as sine what, right? 60 minus 45. And now we're looking at a sine minus 1. Here we go. Let's slide it up here. Give me some room. So sine A minus B. So we got sine A cos B. So sine 60 cos 45 minus cos 60 sine 45. And again, why don't we use, if you have a list of those things, values for sine 60 and all those. So sine 60 is 1/2, right? Sine 60, 1/2, yeah. Cos 45, 1 over root 2 minus cos 60 is root 3 over 2. Sorry, a little bit of spaced out here. Cos 60, no, wait, cos 60 is 1. No, I'm all confused. Cos. Oh, we got this mixed up. Sorry, guys. Got this mixed up. My apologies. Why don't we unfold it here and have a look? Sine 60 is 1/2. Sine 60. Uh-oh. I think I did these ones wrong too. Sine 60, my God. I'm sorry, you guys. Sine 60, let's check it out here. 1, 2, root 3. So sine 60 is root 3 over 2. Cos 60 is 1/2. Sine, so that's my fault here. Just fix that accordingly. Okay, guys, I got that mixed up. So hopefully I won't get this one mixed up. But see how easy it is, right? So sine 60, yes, if we look at sine 60, it's root 3 over 2. Cos 45, 1 over root 2. Minus cos 60 is 1/2. Sine 45, 1 over root 2. So root 3 minus 1 over 2 root 2. And we simplify it again like we did before by multiplying the bottom by root 2 and the top by root 2. Okay? Sorry about that, guys. I didn't mean to guide you down the wrong way. So this is a little bit wrong. You got the right idea, right? It's just about, anyways. So let's sort this out. What do we got here? So given that sine A is negative 3 over 5, let's look over here. Negative 3 over 5 in quadrant 3. So it's opposite over hypotenuse, minus 3 over 5. If you do Pythagoras, you can see that that is 4, so, or negative 4, let's say, and this is sine A here. Then it says cos B is 5 over 13. So cos is adjacent over hypotenuse. So we got this thing here, and that's B, where that's 5, that's 13, and that would be negative 12 if you ended up doing Pythagoras, okay? So now the question is, what is sine A plus B? Well, sine A plus B is right here. That's going to be sine A cos B plus cos A sine B. And what happens here is sine A is negative 3/5. Cos B is 5 over 13. Cos A is negative 4/5. Sine B is negative 12 over 13. And we multiply it out here. Okay, so you get 15 over 65 plus 48 over 65, which is 63 over 65. I think, anyways. Close enough, right? There you go. That's basically it. All right. Let's go down to the next one. How do we solve this? Sine x. Okay, well, hopefully you can see this is sine a plus b, and this is a sine a minus b. So what we need to do is expand both of them. Okay, so sine a plus b is sine x, right? Where are we? Sine a plus b. So sine a cos b, so cos pi over 4, plus cos x sine pi over 4. That's the first one, right? Now let's look at the next one, a minus b. So it's going to be sine x cos pi over 4 minus cos x sine pi over 4. So we've expanded it, all right? And what do we have here? A plus cos x sine pi over 4 minus a cos x sine of those go away. Cos pi over 4. So what you have here is 2 sine x cos pi over 4 is equal to negative 1, right? Don't forget the negative 1. Now cos pi over 4 is 1 over root 2. So I have 2 over root 2 sine x equals negative 1. So multiply this by, so what you end up having here finally is sine x is equal to negative root 2 over 2. So if you remember, that's negative 1 over root 2, which means that that looks like it's going to be a 45-degree triangle. And a sine is negative, so it's going to be down here and down here. And then you've basically solved the whole thing, right? So this is 4 pi over 4, so that's 5 pi over 4, and 7 pi over 4 would be your solutions for this one here. Okay, it's the algebra involved, it's expanding it, it's substituting some values in, it's ended up with an expression that you solve for sine x, and then look at special angle triangles. It's a pretty long question, folks, so I can understand if you're having some issues. Hopefully, however, you'll be able to sort some of this out. Okay, let's have a look at another one here. Good God, it's the same thing over and over, isn't it? So take a sec, give this one a shot. Sine a plus b. So sine a plus b. So sine a cos b plus cos a sine b plus sine a minus b. So it's going to be sine a cos b minus cos a sine b. And you want to finish this off. Well, look again, this kind of would have led into the previous question, right? But whatever, it all works out. We cancel some things out here. So we're left with 2 sine A cos B, which is equal to the right side up there. Okay? I think there's just one more here, ladies and gentlemen. Oh no, I got a couple more. Okay, so let's see what else we have here. Find the general solution for this. Okay, so it's 2 tan x plus, and now we have tan pi over pi. Here we go. What are we going to do here? So tan a minus b. So this is going to be plus, and we're going to go boom boom. Tan of pi minus tan of x all over 1 plus tan pi tan x. Tan pi, you'll remember, what's tan pi? Right? Tan pi. That's way over here where your y is 0, y over x. So tan pi is 0, right? So what happens with this is that you have negative tan x on the top over 1. So it ends up, because that's ends up being 0 on the bottom. So what you have essentially is just minus tan x, right? Which is tan x. And then now you have tan x is equal to root 3. And hopefully you can solve it from that. If you'd like, I can quickly check this out. Right, it's a 31 to root 3. So it's actually a 60. So this would be pi over 3. It occurs all sine, tan, cos. So it's every pi. So now it's plus pi n. Poof, I kind of flew through that because we've done a lot of the solving equations, and I know I've been doing this for a long time. I got one last one here that I wanted to show you quickly so that you can maybe sort this out, but it's working backwards a little bit, right? First of all, I want you to see that you can factor out a negative or a 3 root 2, and then you got sine 2x cos pi over 4 plus cos 2x sine pi over 4. And if you look at this, it's like sine A cos B, right? Cos A sine B. So where do you see that in here? Where do you see that, right? Let's have a look. Sine A cos B, right? Plus cos A sine B. That looks like it's just sine A right there. So this is going to be 3 root 2, and then it's going to be sine A plus B. So it's sine 2x plus pi over 4. Huh. Oh yeah, no, what am I trying? I was thinking I had to solve this. No, we're trying to find the amplitude and phase here, so we need to put this in some sort of form here. So 3 root 2, right? We can take out a 2, oh wait a second. Yeah, so then it's sine, you take a 2 out, you got x plus pi over 8, right? So there's your amplitude. This is your b value. So your period is equal to 2 pi over 2, which is pi. And then your phase shift is left pi over 8. Oh my God, ladies and gentlemen, I know that was a long one. I hope it helps, though. Have a fantastic weekend.